So what is a data lakehouse? Like I covered in the previous module, it is actually a marriage of the data warehouse and the data lake. So you get the best of both those worlds, right? That's essentially what it is. We wanted to reach a point of single source of truth. In the old problem, we had two truths. One, what's in the data warehouse and what's in the data lake. And they were in their own right had their own sources of truth, right? So we don't want the analyst to go and query from both of them and get different results or interpret them differently, where they probably might be thinking that they have two different meanings when they really have one. So we wanted something that works on both ways. What does that mean actually? That means like you need to have the proper architecture that covers what a data warehouse does and what a data lake does. So data lakes are good on the left-hand side of this, where you can ingest data really well into a data lake, and that's what it does. And then the data warehouse part is on the right side of it. If I were to simplify this for you, you would want to think of it that way, is to compute and to consume the data in such a way that it's organized like a data warehouse. We just need the organization part of the warehouse, which takes care of that asset compliance aspect also. And because now the way the data is stored in the data lakehouse, let's call it that, is columnar storage and not row based. So the querying of billions of rows just becomes as fast as you first started your business using the data warehouse many decades ago. So that's kind of like the best of both worlds. And there are kind of like three layers, which we talked about when we think about the data lakehouse. So the first part is the storage. And this is how data is getting stored in the data lakehouse. So they're stored in various forms like Parquet, Avro, or OCR, and they have different benefits on what the use case is. But let's just pick on Parquet. It is a columnar storage. And for the sake of the introduction, that's what you want to think about. How can you store the data at scale? And columnar storage is what should come to your mind. Okay. And then as part of that, how do we take care of the data warehouse part of it, where we want the goodies of how it's stored as a star schema with dimensions and facts that we could join and things like that. And one way to handle that is if you were to write data into a record into the data lakehouse, and I were to write a record into the data lakehouse at exactly the same time, both of our transactions should be committed, where one goes in first and then the second one goes in next, right? And that's how it should be. That's how a data warehouse works. And we want the same effect. It shouldn't go and just replace what you did with mine blindly, but it should be following some asset compliance data writing rules. So that's where the open iceberg table format comes into the picture, where this information is stored in the metadata to keep track of all these internals, right? So that's a very important aspect of the data lakehouse. The third layer is how computes work. So when you write a query to query the data to do the correct kind of joins, you need an engine that takes care of that for you, as opposed to a data warehouse, which is actually a storage surrounded by an engine, like in the case of Oracle, for instance. But in the case of a data lakehouse, storage is the most important part and the compute required for the query. So that's how we save on the costs long term, as opposed to surrounding the lakehouse with a query engine that supports for everything. That's not going to scale. So every time you compute in the data lakehouse, for example, if you take Spark, for instance, it actually spins up a small cluster just enough to run that query. And so that's where the magic is in terms of how it scales for compute. So you could have 1,000 queries query the table, like a billion row table, joining with another billion row table to get what it needs. All these 1,000 queries have its own SQL engine that it allocates in order to just do that one specific job. Think of it as micro engines that's actually running the query to do that. So there's nothing shared between these queries. Unlike a true data warehouse of the past, where everything is kind of shared memory and the shared resources. But here, each of these resources is separate. And because they're separate, they have the full power to execute on that query really fast. And so that was one of some of the big advantages of going to the data lakehouse compared to the data warehouse.